Gasoline has kept the world in motion for most of the past century. But what is gasoline and where does it come from? Gasoline is just one of many compounds that are extracted from petroleum or crude oil. Petroleum is a mixture of thousands of hydrocarbons found in deposits deep beneath the Earth's surface. Scientists think these deposits were formed over millions of years by the action of heat and pressure on the fossilized remains of marine plants and animals. Given the molecular makeup of hydrocarbons, why do you think they're only found underground? Above ground, carbon readily reacts with oxygen, but there is very little oxygen underground, so carbon is free to bond with other elements like hydrogen. Even before Edwin Drake drilled the world's first oil well in Pennsylvania in 1859, petroleum seeping from the ground yielded a number of useful products. The most important was kerosene, which was extracted from the crude by a simple distillation process. Today, petroleum is separated into multiple components or fractions by fractional distillation. This is how crude oil becomes refined. In a refinery, petroleum is heated to about 400 degrees Celsius until it forms a mixture of vapor and liquid. This mixture is injected into a fractionating tower where the fractions emerge at different boiling points. For instance, gas fuels like propane have 1 to 5 carbon atoms and boil between minus 160 and 30 degrees Celsius. Gasoline has 5 to 12 carbons and boils between 30 to 200 degrees Celsius. Kerosene, having 12 to 18 carbons, boils between 180 and 400 degrees Celsius, and lubricants with 18 to 20 carbons boil above 400 degrees Celsius. Some of the crude won't vaporize. This thick, sticky substance is used for asphalt and roofing material. As automobile use grew in the early 1900s, the demand for the gasoline component of petroleum skyrocketed. Yet straight refining yielded only a relatively small amount of gasoline. To get more gasoline, chemists developed catalytic cracking. Hydrocarbons to be cracked are heated under pressure in the presence of a catalyst until they break into smaller fractions that fall into the gasoline range. Cracking also creates a higher percentage of branched chain and ring molecules, which burn more slowly and smoothly than straight chain molecules. Before it's cracked, gasoline consists primarily of straight chain hydrocarbons, which burn too rapidly and cause the characteristic knock that's sometimes heard in car engines. An octane scale of 0 to 100 was developed to give a relative anti-knock rating to gasolines. The highest rated gasolines have the fewest straight-chain hydrocarbons and cause the least knock. More efficient gasolines are being developed all the time, and octane ratings over 100 are now possible. But do you think fuel efficiency is enough to head off depletion of our petroleum reserves? And does a technology like cracking mean there won't ever be a real fuel shortage?